All right. Good morning, boys and girls. How are you doing? How are you keeping up with this lockdown and sit at home uh, issue? So feel free to leave your comments, tell me about how you guys are, sitting tight at home. This very morning we'll be looking at um, a new topic in our mathematics class, and that is on adding and subtracting series of fractions. This lesson has a very core objective. By the end of this lesson, you should be able to add and subtract series of fractions and also be able to carry out multiple operations, multiple adding and multiple subtracting of these fractions. Sit tight and enjoy. Okay, we'll have a quick review of some of the terms we'll be using in this very discussion. We'll look at fractions. Fractions, remember, are parts of wholes and are usually represented in one of the following forms we'll get to look at. But before that, when we say parts of wholes, a typical example is you, the child. You're a part of a family. Your family is a whole unit, and you are a part of the family. So we can say that you are a fraction of the family. Okay, now if we look at a family again, your family is a part of your community. Okay, your family is a part of the community, so we look at the community as a whole unit and your family as a part of that unit. So your family is a fraction of the community, and you can see your community is a fraction of your say local government area or your village or your your state or even the country itself. Okay, so that's the basic view of fractions. Now when we talk of fractions, we have the denominators, we have the numerators, and then the different types of fractions. Denominators are the numbers that divide in a typical fraction. So let's say you're given 2 over 3. 3 is the denominator, 3 is the one dividing, 3 is the divisor. So 3 is the denominator. 2 is being divided by 3 and hence is referred to as the numerator. So the numerator is a number that is being divided in a fraction. So in the fraction 2 over 3, 2 is the numerator, 3 is the denominator. In this other fraction here, 3 over 37, 3 is the numerator, 37 is the denominator. Hope that makes sense to you. All right then. Then the types of fractions depends on the relationship that exists between the numerator and the denominator. If the numerator is smaller than the denominator, it's a proper fraction. You can think of it this way. If somebody were to walk in and maybe your dad and you were to be in a bus and on one seat, if somebody were to walk into that bus and find you sitting on your dad's lap, that means your dad is carrying you. What would he say? Would he say that's proper or improper? Obviously, he would say that's proper. But if he were to walk in and see you carrying your dad instead, obviously, everybody will say that is improper. You see, that gives you a basic understanding of what proper and improper fractions are. So proper fractions are fractions in which the denominator is bigger, greater than the numerator. And then the improper fractions are fractions in which the denominators are smaller, lesser than the numerators. Hope that makes sense. All right. Now, one common feature or property of these two fractions I have mentioned is that their whole number component is 0. The whole number component is what? 0. So if you have a typical proper or improper fraction, you just have a numerator and a denominator, no whole numbers. And once a whole number comes into the picture, we then refer to it as a mixed number. Mixed numbers are a combination, a sum, which means you add a combination or a sum of a whole number and a proper fraction. It is not weird sometimes to come across mixed numbers with whole numbers and improper fractions. That still needs some more simplification. You might come across these when you're dealing or solving fractions. Okay, it's not a really weird thing. It's a normal thing. So when you come across that, you just have to simplify it the more. So mixed numbers are fractions that have the whole number components greater than or equal to 1. So if the whole number part is not a 0, then you have a mixed number. So examples like we see on our screens are one whole number and 2/3. One whole number and in math means addition. So one whole number plus 2/3 will give you one whole number and 2/3. 18 whole number plus 22/73 or 22/73 will give you 18 and 22/73. 3 whole number 4/9. 3 whole number and 4/9. 3 whole number plus 4/9 or 4/9. Hope that makes sense. So quick recap. Proper fractions are fractions that are less than 1. Improper fractions are fractions that are greater than 1. Proper fractions and improper fractions have a 0 whole number components. Mixed numbers are another form of improper fractions, but this time having a whole number component and a proper fraction. All right, now we move into the deal of the day, adding and subtracting decimal fractions in a series. All right, so decimal fractions are usually written in the form a dot b. Okay, where a, the number that you see before the decimal point, is the whole number part, just like we did see earlier. Mixed numbers, whole number components having greater than 1 or equal to 1, and a fractional part. And then we say proper fractions usually have a 0 whole number component and then a fractional part, right? So good. Now when you write these fractions as decimals, like you did get to do in your previous assignment, you find that you come across something like a dot b, 0.75, 0.2, 2.5, 2.89, something like that. Now, the very number you see before the decimal point is the whole number part. The number or numbers you get to see after the decimal point are referred to as the what? They make up the what? The fractional part. Look at the example below. If we were to change 1 3/4 to decimals, it will become, if you were to go through this process of converting first to an improper fraction and then dividing, you have 1 3/4. How do we change to improper fraction? We multiply the whole number by the denominator and then add the product to the numerator. So 1 multiplied by 4 will give us what? 4 plus 3. 4 plus 3 will give us 7. So one whole number, 3/4, is 7/4. Now, we divided 7 by 4. 4 in 7, 4 divided 7 will give you a 1. And you have a 3 left off, right? So that 3 is not divisible by 4. So what we'll do is we introduce the decimal point and feel free to add as many zeros to the 3. So add the first 0, now we have 30. 4 in 30 will give you a 7. That's 28. Remaining 2. Add another 0, making it 20. 4 in 20 will give you 5. So that's how you get 1.75. So another way to look at this is to say 1 whole number and 3/4 is 1 plus 3/4. And then you write it out, change the 3/4 to decimal. You have 1 plus 0.75. Now, look at this board on the right. I simply add the 1 and the 0 because they are whole numbers, the whole number components. So 1 plus 0 will give me 1. So 1 plus 0.75 will give me 1.75. If you have any sort of confusion so far, please feel free to leave comments under this very video. Now, if I have to add or subtract decimal fractions in series, I try to make the whole numbers into decimal forms. So if you have a 1, it becomes 1.0. or 1.00. You can add as many zeros after the decimal point for a whole number. It doesn't affect the value. So 1 and 1.0 are the same. 1 and 1.00000000 are the same. Now once I'm done with that, I then arrange these numbers so that the decimal points are aligned. The decimal points, maintain a straight column. Hope it makes sense. So the decimal point becomes the basis of my arrangement for an addition or subtraction. When you multiply and divide, it's a whole different case. But now, when you add and subtract, the decimal points should all align. So putting the decimal points first and filling the numbers as showed. Look at this example we have here. Add 46 to 0.046. Add 46 to 0.046. Now, the first number there is not a decimal number, but whole numbers can be written as decimals. So 46 becomes 46.0. Now I have my decimal point to help me arrange. Look at the box. I have 46.0. I also have my placeholders there to guide me, my tens, my units, the decimal points, the tenths, hundredths, and the thousandths. So I have my 46.0 put into that box, guided by the decimal point. So decimal point first, 6 in the units, 4 in the tens, 0 in the tenths. You can fill in every other space with as much zeros as you want. Then my 0.046, decimal point first again, 0 in the units, 0 in the tenths, 4 in the hundredths, 6 in the thousands. And now I can add just like I've been taught since primary 1. 0 plus 6 gives me 6, 0 plus 4 gives me 4, 0 plus 0 gives me 0 in the tens place, and 6 plus 0 gives me 6 in the units place. While there's nothing to be added to 4, you simply drop down the 4. You can also put in a 0 under the 4 there if you care, and 4 plus 0 will still give you 4. Hope this example makes sense. We'll look at another one. Alright, our second example. We have solve 86.741 minus, in brackets, 53 plus 0.53 plus 5.3. Now we have a couple of operations here, but we have something that makes it very easy for us, the brackets. If you remember BODMAS, it says brackets of division, multiplication, addition, and subtraction in that order. So brackets to be dealt with first. Now, looking into the brackets, we have 53, a whole number. We have to convert that to a decimal form, so it becomes 53.0. Now, look at the box, 53.0. Guided again by our decimal points. We have decimal points, 3 in the units, 5 in the tenths, 0 in the tenths. You can complete the hundredths as well. 0 in the hundredths, 0.53, decimal point first in the decimal point column, then 0 in the units, 5 in the tenths, 3 in the hundredths. Finally, 5.3, decimal point first in the decimal point column, 5 in the units, 3 in the tenths. Then you add 0 plus 3 plus 0 in the hundredths column gives us 3. In the tenths column, 0 plus 5 plus 3 will give us 8. And in the units column, 3 plus 0 plus 5 will give us what? 8 again. And then finally in the tens column, we have just 5. So it drops down. Or you can say 5 plus 0 because 0 is nothing, will still give us 5. So we have 58.83 as our result from the brackets. Does not mean we are done with our work. We have the 86.741 waiting out there to subtract from. So you make another column, 86.741 minus 58.83. Okay, so decimal point first, and then your 6 in the units, 8 in the tenths, 7 in the tenths, 4 in the hundredths, 1 in the thousandths. And then again 58.83, decimal point first. 8 in the units, 5 in the tenths, 8 in the tenths, 3 in the hundredths. And then we subtract. 1 minus 0 in the thousandths place gives you 1. 4 minus 3 in the hundredths place gives you 1. 7 minus 8, that's not possible. So what do? We go down to 6 and see if we can take 1 unit from the 6 and move it over to the 10th position. Doing that, we'll have 5 units left. And now 1 unit is 10 tenths. 10 plus the 7 we have will give us 17 tenths. 17 minus 8 will give us 9. We had 5 left earlier. 5 minus 8, not possible. So we'll go down to the 10th position, take 110, bring it over to the units position. It becomes 10 units. 10 plus 5 will give us 15. 15 minus 8 will give us 7 units. And then finally, 7 units, 7 tenths left. 7 minus 5 will give us what? 2. So the result of this multiple operation is 27.911. All right, now we have to face our very first multiple operational problem. To have 92 minus 78.3 minus 5.5 minus 2.78. So we have 92 minus 78.3 first, but then 92. We want to change that to decimal form, so it becomes 92.0. Hope it makes sense. All right, now the next thing we do is consider the operations we have. If you want to start from the left to work down to the right, ideal. 92 minus 78.3 first, the answer you get minus 5.5, the answer you get minus 2.78. That's a beautiful way to do this kind of math. It's just that sometimes you might come up with negative numbers, and all the same it should be pretty easy doing it this way. If you, however, want to split this into 2 and deal with one and deal with the other and finally the results, one thing you want to do is be careful how you introduce brackets. If you're going to introduce brackets after a negative sign, like we see here, I can put in my first bracket, open it after right before 92 and right after 78.3. No problems. The second bracket I would want to introduce here would be after the negative sign, the minus sign, before 5.5. Now, if I am to do that, the sign that will be left in the bracket has to change. It will no longer be subtraction. It will become what? Addition. Consider this mini example we have here. It says 5 minus 2 minus 3. If you solve this the traditional way, when we say 5 minus 2 minus 3, you have 5 minus 2 to give us what? 3. And then 3 minus 3 to give us what? 0. Does it make sense? Now, if you were to introduce brackets without changing the sign, then you have 5 minus in bracket 2 minus 3. 2 minus 3 will give you negative 1. 5 minus negative 1 will give you 6. And that gives you a different answer. This 6 is wrong. So when you introduce brackets after a negative sign, do well to reverse or to change the negative sign to the opposite of that. Okay? And that's the positive sign. This is more dealt with under factorization. All right. Now, let's go back to the problem we had. So we have 92 minus 78.3 to be dealt with first, minus open brackets 5.5 plus 2.78. So just like we did in the last two examples, 92.0 plus 78.3 and minus 78.3, and the result is going to be 13.7. Then 5.5 plus 2.78 is going to give us 8.28. Now we have 13.7, the result of the first, minus 8.28. 13.7 minus 8.28. When we solve that, will give us 5.42. I hope you got that right. Finally, let's look at this example. Similar to the last one we just looked at, but this time around we'll have a plus sign right about where we're supposed to introduce the second brackets. You see, with a plus sign, it makes it easy for us to just put in brackets there without changing anything. Okay, look at this mini example. It says 5 plus 2 minus 3. You see, 5 plus 2 is 7. 7 minus 3 is 4. If you say 5 plus brackets 2 minus 3, 2 minus 3 will give you negative 1. And 5 plus negative 1 is 5 minus 1, which will still give you 4. So with that, we can jump right in and solve our math problem. So we have 92.0 minus 78.3 first bracket plus 5.5 minus 2.78 in the second bracket. So with this, we'll have to deal with these two brackets and the results we add. So 92 minus 78.3 will give us, as you can see in the charts, 13.7, while 5.5 minus 2.78 will give us, as you can see in the charts, 2.72. Now, dealing with the results of these two, we have 13.7 plus 2.72. We'll create another chart to add the two of them. Adding the two of them will give us 16.42. I hope this whole thing is clear to you. If it is not, please feel free to leave comments. We can also schedule maybe a Zoom session to be able to interact more and help clear your doubts. Stay safe, guys. See ya.